Every year, over 1 million wildebeest crosses the Mara River during the Great Migration. It is one of the most brutal river crossings on Earth. Thousands don't make it. Currents pull them under, panic causes stampedes, and the one that drown just sink and stay there, decomposing in the water for days, sometimes weeks. And downstream, completely unbothered, hippos wallow for hours in that same river. Crocodiles patrol it, and the wildebeest that did survive the crossing walk right up to the bank and drink from it. Water that is quite literally full of rotting animal corpses, bacteria, parasites, and decomposition byproducts that would put a human in an intensive care unit within a day. They don't get sick in mass numbers. They drink, they walk out, they graze. Meanwhile, if you or I filled a bottle from that exact spot in the river and drank it, we would be dealing with a medical emergency by nightfall. So, what is actually happening inside these animals that isn't happening inside us? The answer isn't one trick. It's not a single organ or a single adaptation. It's an entire stacked system built over millions of years where multiple defenses are working at the same time, each one catching whatever the last one missed. We are going to go through exactly how that system works, layer by layer. And along the way, we are going to answer a question that most people get completely wrong. If I ask you to guess which animal has the single most powerful, most corrosive stomach acid in the entire animal kingdom, you would probably say a lion or a crocodile, maybe a hyena because they crunch through bones. You would be wrong, and the actual answer is stranger than any of those. But first, let's start with the first layer of defense, because it is the one doing the heaviest lifting: stomach acid. Human stomach acid sits at the pH level of roughly around 1.5 to 3.5. That's already acidic enough to break down foods and kill a decent chunk of bacteria we swallow. Dogs run hotter, typically between pH level of 1 and 1.5, acidic enough to dissolve bones, which is a part of why a dog can eat a raw meat and that would send a person to the hospital. But there is an animal that makes even a dog's stomach look mild. An animal whose stomach acid gets close to pH 0, pH value 0, essentially as corrosive as battery acid, strong enough to destroy anthrax spores, botulism toxins, and even rabies virus on contact. We will come back to this exactly who that is, keep it in mind. But for now, back to the wildebeest and the river. Before contaminated water even reaches the stomach, it passes through the mouth. And that's where the second layer kicks in: saliva. Saliva in most mammals isn't just lubrication, it's chemically active. It contains lysozyme, an enzyme that physically tears open bacterial cell walls. It contains lactoferrin, which binds up iron so bacteria can't access the mineral they need to multiply. And it carries antibodies that are already primed to recognize local pathogens. Horses take this to an extreme, producing up to 10 liters of saliva in a day while grazing, constantly diluting and neutralizing whatever they take in before it even reaches the gut. So, by the time contaminated water hits the stomach, it's already been chemically filtered once. Then it hits an acid bath most human stomach could not survive drinking. And whatever makes it past both of those checkpoints runs into layer 3: speed. In many animals, especially carnivores, the digestive tract is short and fast. Food and water moves through quickly. That matters because a bacteria needs time to establish a colony and start causing a damage. A slower gut like ours, like humans, gives bacteria a longer window to settle in and multiply. A faster gut simply doesn't give them that chance. It's less about killing every pathogen and more about not giving them time to become a problem. And then there is a layer that took evolution the longest to build: the microbiome. Every animal that regularly drinks from the same water source develops a gut ecosystem calibrated to that specific environment. Billions of bacteria and microbes that have essentially met the local pathogens before and know how to respond. It is not immunity in the way a vaccine gives you immunity. It's familiarity, built through repeated exposure over an entire lifetime. A wildebeest that has grown up drinking from the Mara River system has a gut that has, in a sense, been negotiating with that river's bacteria since birth. This is also why this story falls apart if you take a domestic animal, one raised entirely on filtered water, and suddenly let it drink from a wild source. Its microbiome was never calibrated for that. It's not protected the same way. Horses handle this slightly differently because they are not carnivores with a short, fast gut. They are hindered fermenters, meaning most of their digestion happens in a massive fermentation chamber, the cecum, which in a full-grown horse holds around 30 liters and is packed with one of the most diverse microbial communities in the animal kingdom. When a new pathogen enters that environment, it's not landing in an empty space. Every ecological niche is already occupied. The existing community crowds it out simply by being there first. It is a biological fortress built on sheer occupancy rather than acid or speed. Now, back to the animal with the pH level 0 in stomach. It is not a mammal at all. It's a vulture. Vultures feed almost exclusively on carcasses in advanced stages of decay. Meat that carries anthrax, botulism, rabies, and bacteria's loads of would kill nearly any other animal on the planet almost instantly. Their stomach acid is so extreme that it doesn't just digest the meat, it sterilizes it. Pathogens that survive in almost every other environment on Earth simply cannot survive a vulture's stomach. It's arguably the single most extreme digestive defense system evolution has ever produced. And it exists specifically because vultures occupy an ecological role that requires it. Nature built the ultimate cleanup crew and gave it the chemistry to match the job. So go back to that riverbank. A wildebeest drinking from water full of decomposing bodies isn't surviving by luck. Its saliva is already breaking down bacteria before it swallows. Its stomach acid is destroying most of what's left. Its digestive speed denies bacteria time to establish, and its microbiome, turned over a lifetime to that exact river, is standing by to handle anything that is familiar. Four separate systems, each catching what the one before it missed. That's the real answer. No one adaptation, a whole stacked defense network refined over millions of years of drinking exactly the kind of water that would end us in a single sitting. And humans didn't lose this because we got weaker. We solved the same problem a completely different way. We invented fire, we invented cooking, and eventually we built water treatment systems that remove contamination before it even reaches us. We externalized the filter instead of evolving one internally. It worked so well that our bodies simply stopped needing to be as extreme. But here's the thing about a defense system this powerful. It has a weaknesses too, because even a vulture's stomach, even a wildebeest microbiome, even a horse's fermentation fortresses, all of it can be defeated by one thing, and that isn't bacteria at all, and doesn't care how strong your stomach acid is. That's a different video, but once you know what it is, you will never look at a still, calm looking pond the same way again. We will talk about that.